In this lesson, I'm going to show you how to solve three trig problems that need to be solved using half-angle identities. What I've done for you is I've put the half-angle identities on the top of the screen so we can refer to them as we go through the problems. But at some point, you're going to need to memorize these identities for yourself. Number one, use a half-angle identity to find the exact value of the sine of pi over 8. For a problem like this, the first suggestion that I would make is to convert pi over 8 to degrees by multiplying by 180 over pi. The pi's are going to cancel out, and you're going to be left with 22.5. So this problem becomes sine of 22.5. Now, 22.5 is not a benchmark angle that you've memorized. However, it is half of a benchmark angle you've memorized, and 22.5 is half of 45. So I'm going to go ahead and write this as the sine of 45 over 2. In doing this, I can clearly identify what A is. As we look at the identities in the box on the top, I need to have A over 2. So in this case, the A is aligned with 45. The next thing that I'm going to do is just write down the formula. And when you look at the top, a lot of the formulas look similar. One of my students from many years ago had a trick to help distinguish between the sine half-angle identity and the cosine. And that trick, it may seem silly, actually works for me today. He said sinus minus. The sine formula and the cosine formula are identical except one has a minus and the other one has a plus. And the one that has the minus is the one that goes with sine. So he said sinus minus. Maybe that'll help, maybe it won't. So I'm going to start by writing down the formula. 1 minus cosine A, or 1 minus cosine 45, divided by 2. Now, another part of the formula which we can't neglect is this plus or minus out in front. And this plus or minus doesn't mean just jot down plus or minus. You actually have to pick plus or minus. We're going to make that commitment right now, but to do that, I'm going to look at the beginning of the problem. In the beginning of the problem, we have an angle 22.5, and 22.5 is in quadrant 1. And I know that in the first quadrant, sine is positive. So I know the answer, the evaluation of this angle is going to be positive. And that's how I make my decision whether it's plus or minus, by looking at the original problem and asking, what quadrant am I in? So again, because 22.5 is in quadrant 1 and sine is positive in quadrant 1, I'm going to put a positive here. Even though it's a bit redundant, I'm going to put that just for emphasis. Now you'll notice I left a big blank for the cosine of 45. The cosine of 45, if you'll recall, is root 2 over 2. Now, in writing this in, we have this complex fraction under the radical. It's starting to look a little bit messy, but there's a very quick way out of this situation, and that is to multiply by a useful form of 1 under the radical. So I'm going to start by just extending this radical bar just a little bit bigger, and I'm going to partition off what I have already. And my useful form of 1 is actually going to be 2 over 2. 2 over 2 is 1. It's not going to change the value by multiplying by this, but it's going to make it look less complex. On the top, when I distribute the 2 through, 2 times 1 is 2, and 2 times negative root 2 over 2 is negative root 2. So I end up with 2 minus root 2. And the bottom is 2 times 2, or 4. Now when you take a square root of a fraction, the rule is you have to apply the root to the top and the bottom. Well, in this case, the denominator is a perfect square. The square root of 4 is 2, so I can simply write the square root of 2 minus root 2 all over 2. This answer might seem a little odd looking, having radicals inside of other radicals, but if you go ahead onto your calculator and you type in sine of 22.5, remembering to be in degree mode, and then you type in the square root of 2 minus root 2, then divided by 2, you're going to get the same thing. So expect answers to occasionally look like this with radicals inside of other radicals. Let's take a look at a second problem. Problem number 2 says, use a half-angle identity to find the exact value of the cosine of 11 pi over 12. Like the first problem, my first strategy would be to convert that radian measurement into degree. Let's take 11 pi over 12 and multiply it by 180 over pi. The pi's are going to cancel out, and the 12 and the 180 leave you with a 15, and the 15 times the 11 that's already there is going to leave us with an angle measurement of 165 degrees. So I'm going to go ahead and rewrite the problem as the cosine of 165 degrees. Now, 165 degrees is not a benchmark angle that you've memorized. However, if we multiply that by 2, it ends up being 330. So 165 is half of a benchmark angle. So I'm going to go ahead and write this as the cosine of 330 divided by 2. Now we're going to use the cosine half angle formula, and if we look at the top in the box where that formula is, I need to start off by figuring out what A is. And A is going to be the number in the numerator. So A in this case is 330. And I always like to clearly identify what that is because I'm going to be using it several times later in the formula. So I'm looking at the formula, and like the problem number 1, I've got to decide whether I need the plus or the minus. I'm not going to write plus or minus. I've got to choose one or the other. And as a reminder, to do this, I need to go back to the original problem. The original problem is talking about the cosine of 165. Well, 165 is in quadrant 2, and I know that in quadrant 2, cosine is negative. So this answer overall needs to be negative. So I'm going to go ahead and put a negative sign there. Now the little trick that my student had told me was sinus is minus. Well, cosine is going to be plus. It's the other one. So I'm going to write down 1 plus cosine A, or 1 plus cosine 330 over 2. Okay, so I'm going to go up here where I have a little bit more room. I'm going to rewrite this with a big blank so I can evaluate the cosine of 330. Well, 330 is in quadrant 4 and has a reference angle of 30. Cosine is positive in quadrant 4, and the cosine of 30 is root 3 over 2. So that's what's going to go in the blank, root 3 over 2. Like problem number 1, I've got a situation where I have a complex fraction under the radical. Don't be alarmed, though. We can fix this real easily by multiplying by a useful form of 1, again, times 2 over 2. It's important that I keep all of this under the radical, so I'm going to go ahead and extend the radical, just making it a little bit longer. Okay, the negative is going to come down. I'm going to make another big radical here, and I'm going to distribute the 2 through on the top and the bottom. On the top, we end up getting 2 plus root 3, and on the bottom, we get 2 times 2, or 4. But using the property of roots of radicals, we know that that radical is going to apply to both the numerator and the denominator. So it's really going to be the opposite of the square root of 2 plus the square root of 3 all over 2. Now, dividing by 2 is like multiplying by a half. So I have seen in the back of some books where they list the answer, instead of expressing it like this, dividing by 2, I've seen this. These, of course, mean the same thing, but I have had students who look at this answer in the back and they don't know what it, they're just a little confused at first. So I just want to remind you that dividing by 2 is the same as multiplying by a half, and that these are both equivalent expressions. So here's example number 2 of using a half angle identity to evaluate a non-benchmark trig angle. By now you're probably really getting the hang of this, but we do have one final example, and that is example 3, which asks us to use a half angle identity to find the exact value of the tangent of 7 pi over 8. Let's start by converting that to degrees. In this case, we end up with 157.5 degrees. So I'm going to go ahead and rewrite this as the tangent of 157.5 degrees. Now, 157 degrees is not a benchmark angle, but it is half of a benchmark angle. 157.5 happens to be half of 315. So I'm going to write this as the tangent of 315 degrees over 2. I'm now going to clearly identify what A is, and A is going to be the 315. It's this number on top. I make a point to write down what A is since it's used again later on in the formula. Now, one interesting thing about the tangent half angle identities is that I have 3 choices. Most students tend to shy away from option number 1 because there's the radical and there's the whole decision of using the plus or the minus, so I don't blame them. You could use 1, you could use 2, or you could use 3. You should get the same value, but it's just whichever one you find easier to work with. So for this problem, I'm going to use option number 3. So I'm going to go ahead and I'm going to write the sine of 315 over 1 plus the cosine of 315. Okay, now I'm going to rewrite this whole thing but leaving blanks in the place of each evaluation. 315 is in quadrant 4, and the sine of 315 is going to be negative root 2 over 2. The cosine of 315, on the other hand, is positive root 2 over 2. Once again, we have the issue of a complex fraction. Don't be alarmed. Let's multiply the top and bottom by a useful form of 1. In this case, that'll be 2 over 2. That was actually the case for the other ones as well. If I multiply the top and the bottom by 2, I end up getting negative root 2 on the top, and then on the bottom I get 2 plus root 2. However, you're not allowed to have a radical in the denominator. So I'm going to multiply by another useful form of 1, this time the conjugate of the denominator, or 2 minus root 2. Distributing the negative root 2 through on the top, I get negative 2 root 2 plus 2. The bottom is multiplying a binomial by its conjugate. And if you've watched other videos of mine, you know that when you multiply two binomials together, you traditionally FOIL. But whenever you multiply a binomial by its conjugate, the outer and the inner terms cancel, so you're just left with the first and last. The product of the first is 4, and the product of the last is going to be minus 2. And 4 minus 2 is just 2. And then if we simplify this by doing a many over 1, this over this plus this over this, we're going to end up getting negative root 2 plus 1. And I think it's important when you're learning to make sure you're doing it correctly by entering this on a calculator and also entering the original problem on the calculator to see if you're getting the same value. So here were 3 examples of using half-angle identities to evaluate non-benchmark trig angles.